Okay, so I will go ahead and begin. Again, I'm the Technical Sales Manager at Morningstar, and this is the first of 3 presentations today we'll be giving. Another one at 1 p.m. and then another at 10 o'clock tonight for our friends over in Asia and in Australia. So once completed, we'll also be sending out a link to the recorded version of this webinar, so you can feel free to watch it as many times as you would like. And hopefully the sound of my voice does not get too much for you to take. Anyway, so let's go ahead and begin. Again, thanks everyone for attending. What we'll be talking about today is the TriStar Mppt 600 volt controller and the ground fault protection device. This product is used in conjunction with the TriStar Mppt because, of course, for U.S. electric code, a ground fault protection device is required when you have an array on a dwelling. So we're offering both of those products. The TriStar Mppt leverages Morningstar's history of engineering excellence. We really wanted to take our time and get this product done right, and for any of you that have been following this product's release, we've certainly taken some time to get it to market, and now it's finished and we're really excited to have it available and really proud of the features that it offers. It uses our TriStar Mppt Tracking technology, and that's something that's been used on our SunSaver Mppt, TriStar Mppt 150, and now this product. And what that does is it basically is a very high-speed sweeping algorithm that will find the maximum power point extremely quickly on anything up to a 600 volt array. So what ideally that does is it does not require any type of dynamic tracking or any of the slower technologies that are out there. It finds the maximum power point extremely quickly and stays on it through any kind of shading or other changes in irradiance. The TriStar Mppt 600 volt can be purchased with or without a pre-wired disconnect box, and I'm going to talk a little bit more about that later. And optionally, you can also add the TSM2 600 volt version of our internally mounted meter display. So a little bit about the specs of the TriStar Mppt 600 volt. It's a 3.2 kilowatt power rating, and that's the maximum wattage nominal. It's designed to charge a 48 volt DC battery. So unlike the others, it does not work at 12 or 24 volts. It's only for larger systems at 48 volts. Maximum 60 amps continuous battery current. And the device will actually current limit up to the 60 amp limit. So if you have a larger array than 3.2 kilowatts, you'll only get 60 amps of output. All right, but it will be able to consistently operate at that level and maintain that throughout the day. Okay, it's designed basically to run at full power. It has a very wide array input operating voltage, so it can take anything from 5 to 525 volts at the input and function. I'm going to talk a little bit more about what that actually means later. For questions regarding the fact that the input voltage is actually lower than the battery, this is a buck boost design, so we are able to still take a voltage even lower than battery voltage and still actually charge the battery. Okay, so it is not just a buck converter. It's passively cooled. That means there's no fans, so very high reliability because we don't have to push air to keep it cool. And we also do offer 4,500 watts of transient voltage suppression built into the product for lightning protection. As I said, it uses our TriStar algorithm, so this is going to make sure to harvest the maximum energy from the solar array. And again, this is a technology that we've utilized in all of our product range to efficiently find the maximum power point. One thing we're also very proud of is that the fact that this product has a peak efficiency rating of 97.5%. So what we did with this design was we engineered it to operate extremely well at a specific point, and that would be a high voltage input, between 300 to 400 volts VMP, and output to a 48 volt battery. So because it was designed to do that specific voltage conversion very well, the efficiency is maximized. So we're looking at about 97.5%. The TriStar Mppt 600 volt has many of the same features as the TriStar family has always had, and that includes remote connectivity through all the various data communication ports. It includes standard data logging inside the controller. Very simple dip switch based plug and play setup. That means there's not a complex meter structure where you have to kind of dig into 5, 6, 7 layers of meter menus in order to change settings. We have simple battery profiles set up in the dip switches, and in many cases you don't even need the meter to set it up. You just click a couple dips and leave it in place, and it's good to go. It has an optional onboard or remote meter option. Okay, so the TriStar meter family has a new feature, which is the 600-volt version, and that will give you additional information pertaining to this product. Like the other controllers, it's able to be used with up to 4 units in parallel, so you can actually aggregate the data from all 4 controllers onto one meter display. And then lastly, we also offer the built-in communication protocols and true Ethernet functionality that we've offered on the TriStar Mppt 150. So that's all included on these units as well. So a little bit about the different models. As we said, there are 2 different models available. Okay, first of all, on all versions of the controller, you have the following features. Okay, and these are high-low voltage barrier, which of course is going to separate the 600-volt components from the low-voltage battery side components. We have multiple M20 knockouts for European glands, if you wish to use those. We have our inch and 1.25 knockouts, and these are all located on the bottom of the controller. On the sides, you'll see a lot of additional knockouts as well that allow pass-through on the bottom to be run, so you can actually string 4 of these together and share a common ductwork through the controllers. And also the remote temperature sensor is included by default with this product because it is a battery charger, so we give you the RTS in the box. Now specifically, the Mppt 600 volt 48 is just the standard controller, and that's the one you see there at the top, and that version is just the controller itself, so it has no BOS included. It's just a conduit box. So that would be if you have external disconnects and breakers. Then what we offer is on the disconnect box version, we give you the following additional features. First is a lockable 600 volt DC 25 amp PV disconnect, so that's included. We give you 150 volt 63 amp battery breaker, so that's both obviously a disconnect and a circuit breaker design as well, included in the controller. There's 4 bus bars inside for both the positive and negative of the solar PV and the battery, so you have several landing points for your wiring. There's 2 DIN rails inside as well that give you the option of maybe reconfiguring the hardware, or in some cases if you had 2 strings and you wanted to add a fuse holder, you could do that as well. And this is all designed for grounded systems, so we give you a single pole breaker and disconnect, and that could be used in either a positive or a negative ground configuration. Okay, moving right along. This is an internal shot of the disconnect box, so you can actually get an idea of what you're seeing inside. Let me try my laser pointer out here. You can see here's the disconnect for the PV. We have DIN rails located here and here. Here is all of your battery terminal wiring blocks and your PV terminal blocks on the other side. This is a voltage divider that's going to keep the high voltage component separate from the low, and then we actually have a pass-through that allows you to run both high and low voltage wiring separately through the bottom. And if you made up 4 of these devices, then you can actually run them all through the bottom of the controller. So this is Morningstar's first exploration into some of these additional balance of system components that we're beginning to offer with the products to make them easier to install. The TriStar Mppt delivers really excellent performance. As we said, best-in-class power efficiency, 97.5% peak efficiency. You're going to get our standard 4-stage charging algorithm. So this is the standard bulk, absorption, float, and equalize that you've come to find in all of our products. Again, easily set up with dip switches. And we're also utilizing our same thermal and mechanical design. And that means that these products are designed for off-grid use. Okay, so we're leaving out fans and relays, so there's no moving parts. We've provided epoxy encapsulation, so a lot of times the inductors and various components inside are sealed in epoxy so that they can't easily corrode. And we conformally coat all the circuit boards so that if you have any kind of salt or humidity environment, possibly near the ocean, that you have an extended lifetime for the products. One of the biggest benefits of this product used in just standard solar applications is the fact that you're wiring the input voltage usually at an operating point of 300 to 400 volts. Okay, so what that does is that gives you a lot greater distance that you can run the PV array before you have to convert down to low voltage to charge the battery. Okay, for that reason, we have a lot of new advantages, especially economic considerations that allow you to do systems that you weren't previously able to do. For instance, talking to some customers in the northern part of Canada, they were often using homes or installing PV systems at homes that were in the woods, but they had a clearing available to put a ground mount PV array. But the distance in the wire gauge required to make that long of a run was not really practical. In this case, you can now do that because you can use smaller diameter wire. You eliminate the combiner box, fuses, the additional wire runs to the combiner box, and then of course the labor associated with that. And we've done some calculations and found that the economic benefits really start to take place at about 30 meters and beyond. You start to see significant cost savings that can actually help the added cost of the controller pay for, basically take the place of those system costs. Okay, so it starts to not only become an economic benefit, but a technical one as well. Talking a little bit about the input voltage parameters, this product does operate at a very wide input voltage range, and just wanted to give you a little bit of background info. This is a graph from the manual. It has a 200 volt minimum operating voltage, and that is at 100% full power. So it will actually operate below that point. You just get a linear D rate, as you can see on the graph. The maximum operating voltage at 100% full power, 60 amps output, would be 425 volts. It can continue to operate up to 525 volts, but again with a D rate. And then when you get past a certain point on the open circuit voltage, around 550 or so, you're beginning to get into a high voltage condition where the product would not be able to operate because you're approaching the maximum open circuit voltage, which would be 600 volts. At that point, that's where the components are actually rated, so you would not be able to operate if the voltage was that high because the controller would be in a shutdown state. Okay, so you do have to basically size it so that even in extreme cold, you're not going to get into those high voltage areas near the engineering design threshold. What we're going to do is we'll be updating our string sizing program on our website very shortly, and that's going to give you all the relevant information regarding how exactly to size it and taking into account modules, temperature, power D rates, and so on. Okay. To talk a little bit about the communications, this product uses the standard communications suite that we've offered on the other TriStars, and that would be we use Modbus communication protocol, both Modbus RTU as well as Modbus TCP/IP. That's broadcast over Ethernet. We also utilize SNMP for telecom folks out there, as well as SMTP for email notification. Okay. The interfaces are an Ethernet port and also RS-232 and 485. Okay, and again, we pride ourselves in using standard communications, and these are offered on board, so you don't need to buy expensive adapters. There's no proprietary programming that we've done to make it harder to work with our products. In many cases, you can take our controllers and design or get data using your own equipment. There's data logging available. We have internal log data that's stored in the flash memory in the controller. Real-time data can be accessed remotely if you want to see what's going on at that point in time. And this controller also features an internal web page that will be displayed directly from the controller, so you can view easily the operational conditions of the controller using any web browser. And that includes a phone or any other type of tablet that would be able to show you a simple web page, so you can know what's going on with the system. And that doesn't require any type of network service or web provider. When the controllers are networked together, interact with each other, and they can share a single meter to display all the data from 4 controllers in one. And additionally, remote monitoring is available. If you have additional questions about some remote monitoring, there's some additional communications documents on our website that tell you how to configure that. And we're going to be doing some trainings in the coming year that talk even more to that type of functionality, is remote access. Okay, a couple additional features that are coming soon for this product. The product is being released now and is will be available starting at the first week of December for shipping. Some additional features that are going to be added shortly after that are coming soon that I wanted to talk about quickly. One is we are going to be offering a DC transfer switch that be connected to the solar PV input of the controller, And if you have an existing grid tie system, this DC transfer switch would give you an easy way to actually switch the array from a grid tie inverter over to the 600 volt MPPT. So if you had an existing grid tie system and you wanted to utilize that array untouched for battery charging, you can do so with this transfer switch. Okay, so that's something we're going to be offering. And another feature coming along shortly is additional software that allows the paralleling of up to 4 controllers. And these 4 controllers will actually communicate via Ethernet, and they would track and sweep the maximum power point as if they were one controller. Okay, so this isn't parallel battery charging, it's actually paralleling of the input of the controller. So to a wind turbine or to a large PV array, this would appear as one extremely large charge controller. Okay, they would sweep and track as one device. Okay, so this allows some new opportunities with large wind turbines or existing combined PV arrays that are already greater than 3.2 kilowatts. You can now go 12 to 15 kilowatts in size and be able to easily charge a 48 volt battery through this down conversion. So these two features, the DC transfer switch and the paralleling software, will be coming out in the coming months. Okay. So in summary, the 600 volt allows a high voltage PV array to be utilized with a low voltage system. Okay, so we think that offers new opportunities for ease of wiring. It allows customers that are familiar with high voltage strings to basically utilize that same type of array wiring that they've always been using, except now they can use it with a charge controller and charge a 48 volt battery. It offers the same ease of use, accessories, and installation options that the existing TriStar family of products has offered from Morningstar. It gives you advanced functionality such as input paralleling, which is a bit new to charge controllers in the industry, so you can utilize very large PV and wind systems. And it also offers the ability of a 600 volt PV array that's already in an existing grid tie system to be transferred over to charge batteries without changing the array configuration or adding any kind of expensive AC coupled hardware. Okay, so we're looking forward to supporting those applications a lot in the future. Okay, so now moving on from the charge controller, I want to talk a little bit about Morningstar's ground fault protection device. Again, for some of our international customers, this is, of course, a useful safety device around the world because it's able to offer the detection and isolation of ground faults. Okay, so it's always useful for anyone that wants to provide that kind of safety and protection in their system. It is required by code in the United States, so we are offering it both in a 150 volt and a 600 volt version for our family of charge controllers. So if you're familiar with existing solutions, usually how ground fault protection is done is a fuse or a small breaker is actually located between the negative ground bond in an off-grid system. Okay, so to go to a bigger shot here, you can see that what we have is this fuse or breaker is located where the negative of the system is bonded to ground. This happens to be a grid tie system, but it's the same in all types of applications. What it does is this provides a current path for the ground fault. So the ground fault has to actually occur and provide current flow through this bond when it's trying to return to the negative. Okay, upon breaking this, that's when the ground fault is detected and tripped. But there are a lot of weaknesses in this type of solution, and that's what I'm going to talk a little bit about because we're proposing a different way of doing this. What Morningstar does is instead of predicting that the current will flow through that breaker or fuse, we actually are monitoring the current through the entire system. Okay, we have a current sensor here, and this works very similar to the way an AC-based ground fault protection device, such as those outlets in bathrooms, are designed to work. They monitor current, and if there is a equal flow, as there should be, what goes out comes back, then your system is fine. If there is an imbalance detected using this current measurement device, that imbalance indicates that current is being lost somewhere. We don't necessarily know where, but it's not returning the way it should. Therefore, there's a ground fault, and the system is shut down. Okay, we actually break both the positive and negative of the system. Okay, this is our current measurement device. This is the electronics that power the system, and then it's used with additional breaker stacks to actually perform the disconnect. Okay, so this wire aperture is where you would actually wire the positive and negative, and it would actually detect the ground fault through an imbalance at that location. So to summarize the differences, the existing solutions, when they trip that fuse, when that fuse blows, it breaks the earth bond. Okay, now you've basically taken your ground and removed it. Okay, so you've broken the bond that is supposed to be in place. Normally grounded components can now float to a potential difference from ground, potentially a negative difference. That's a safety hazard, and you've detected the ground fault, but you've put it into a less safe state than it was in before. Also, these fuses are not exactly precision devices. They're a bit crude. They don't blow at specific levels. In some cases, you can have a ground fault exist and not have enough current to trip or blow that fuse. Morningstar's ground fault protection solution works like a traditional AC ground fault interrupt. Okay, it maintains the integrity of the earth bond at all times. It detects an imbalance in current flow. We trip at a much lower fault current. When we do trip, we break both conductors, so both the positive and negative are disconnected, so it completely isolates the system. For that reason, we don't require any kind of warning at the battery because both of the positive and negative are tripped, so it's completely isolated. It's usable in both positive and negative ground systems, and even for larger arrays. You only need one ground fault protection device, even if you're using many of our charge controllers. It also makes it easier to locate and troubleshoot the ground fault. And our indicator has both visual and audible electronic notifications, so there's a little more clear idea of what's happened with the system. So we have a bicolor LED that gives you current status. We have an audible beeper. There's a test button to actually to put the system through a test and trip the breakers to make sure that everything is functioning okay. Here's a rough idea of the general specs for the product. It does run off the battery, so it has an input voltage of 8 to 80 volts, very low self-consumption. The ground fault threshold current is 300 milliamps, so that's a much lower current level than these existing fuses that are used to detect existing ground faults. What we do is we send a 12-volt trip signal to the breakers, and then that will actually disconnect the entire system. And as I said, we have 150 volt or 600 volt versions. Relays are used to trip the breakers. The products, both the disconnects are listed using UL 489 and 1077, and then the entire package is also relisted to meet UL 1741. Okay, so this is an entirely listed product for both the 150 and 600 volt versions. And if you need any detailed certification information, we have that available. Okay, so here's some examples of the products. In this case, this is the 150 volt version. You can see we're breaking both legs, and then this is the trip breaker on the end. So when that is thrown, it takes both the positive and negative with it, and the entire system is disconnected. And these conduit boxes are designed and made up with the TriStar Mppt 150 and also with the 600 volt. In this case, you can see here we have ganged breakers to fully isolate both the negative and the positive of the array. Okay, so obviously this is a lot larger because we have to deal with 600 volt tolerances, but the functionality is the same. Here's an example of the inside of the package, just to give you an engineering drawing here. So here's the wire aperture itself, so the wiring is going through here, and then we have both the positive and negative legs. One thing to summarize for everyone is the US dollar retail pricing for the products. So here we have both models of the TriStar Mppt 60 600 volt, the regular standard box, as well as the disconnect version that includes the PV disconnect and battery breakers. So one of the suggestions given to us was to include some of this hardware, and that's why we're offering the disconnect box version of the product for customers that want these existing BOS components already integrated into the controller. The TSM2 600V is a special version of the TriStar meter that will be utilized with the 600 volt charge controller. That's available as well. And then both the 150 volt and 600 volt ground fault protection devices. Again, that's US retail pricing. So definitely speak with your wholesale distributor to get an idea of your reseller price. Okay, to learn more about Morningstar's 600 volt MPPT, you can definitely take a look at our website and you can see all the information there. We have the existing data sheets as well as the operation manual, and this product will be shipping. We're taking orders now. Pricing is released, and we'll be shipping these the first week of December. Okay, and I would like to go ahead and take a pause there, and if there are any questions, I'm going to go ahead and take a look at our questions section and see if I can address a few of those. Give me just one moment. Okay, a few quick questions. The Ethernet speed is actually 100 base T, which is more than enough for the ability to get remote data. And what the controller will do is when we have the ability to parallel up to 4 of these controllers, that 100 base T Ethernet will actually create a high-speed link so that the controllers are intercommunicating with each other, and they will track and actually follow the maximum power point of the array as if they were one product. Okay, if there are any additional questions, go ahead and get them submitted. We do have one question. Will this operate on a 24-volt battery bank? No, at this time, the controller was designed only to be used with larger systems. Rather than try to support both a 24-volt and a 48-volt battery, we decided to just support 48 volts. And that's because we were really trying to get the operational efficiency of the controller as high as possible. And to get that 97.5, we sort of had to optimize it for one specific type of buck conversion, okay, and that was about 400 volts input down to a 48-volt battery. Okay, so in order to do that, we needed to just pick a 48-volt bank. Not only that, but because it's used in parallel systems and larger wind systems, you're trying to get the current as low as possible, so 48 volts is usually going to be the standard in most of those applications. Okay, so it's a 48 volt only. One question about the advantages of paralleling versus segmenting charge controllers. When you have a design, let me actually jump back to this slide. One of the benefits of combining the controllers together is that in this case, in a wind turbine, this is really the only way you can get charging at all, because you have to basically create a 12 kilowatt charge controller. Okay, so in this case, it's the only solution you have. If you wanted to do it with a larger pre-combined solar array, you could do that as well. Okay, but when you do that, it's going to track it as one giant array. Okay, so that gives you some new functionality and the ability to take a wind turbine in at 300 volts DC and charge a 48-volt battery. However, if you wanted, you can actually segment and use 4 charge controllers independently, each with their own PV string. So that would be like 4 smaller arrays. When you do that, you're actually creating a multi-string tracker. You'll notice that several grid-tie inverters that are on the market will often advertise that they have multiple string inputs that are tracked independently. So that can provide advantages when you have partial shading on one string, the other strings are not affected. Okay, so you always get a benefit when you have individual strings because they're isolated from each other, so you have better overall efficiency. But in the case of paralleling the controllers together, sometimes that's the only thing you can do when you're trying to support larger charging sources, like existing arrays that are already combined or a wind turbine. Okay, so we give you both options, and you can use either one depending on what your needs are. Okay. Question about the DC transfer switch. Again, this product is still being finalized in development, but essentially what it will be is a DC transfer switch that will accept up to a 600 volt input, and it would allow the automatic transfer of the PV array from the grid tie inverter to our 600 volt charge controller during a power failure. Okay, so that an existing grid tie system that is pre-wired and already completed could have a 600 volt charge controller added to it after the fact. You would not have to reconfigure the array at all. The transfer switch, when the power fails, would throw the array over to the charge controller and allow you to charge a 48 volt battery. So you are given some power in an off-grid way when there's an outage. Okay, so it allows you to use your grid tie system for a lot more than just sitting there unused during an anti-islanding condition. Okay, so during this time, you can charge a battery. You can then use an off-grid inverter, such as this one of any size, to provide backup for your loads. So it's a little bit different way of looking at backup, and it's available because we have a 600 volt input on our charge controller. So offering that DC transfer switch will enable this. It's being designed so that you could use several of our charge controllers. I think the current maximum amperage we're looking at now, I think, is about 100 on the input. So by doing so, that would easily, since we have 15 amp inputs to each of the controllers, that would easily give you up to 4 of them that could be used to transfer a very large array over and charge an off-grid battery bank. Okay. So I hope to provide you guys with more information about the DC transfer switch in the coming months. Okay, I believe that is it for questions. If there are any additional ones, please input them. We're going to go ahead and go offline, and thank you very much for attending our webinar. Again, if you want to reach out to me personally, you can do so. We're all happy to answer any additional questions you have. And thank you much for attending Morningstar's webinar today. Again, we'll be rebroadcasting this. Well, not rebroadcasting. We'll be giving this webinar again live at 1 p.m. today, Eastern Standard Time, for our customers on the West Coast that was to participate. And we'll be doing this again at 10 o'clock p.m. tonight, also Eastern Standard Time, so that our customers on the other side of the world will also be able to participate. So if anyone is a night owl and wishes to join that one as well, feel free. We're happy to talk to you again. Okay, thanks very much, everyone. We appreciate you attending, and we will look forward to supporting you with our 600 volt charge controller on the market. Have a nice day.